Hello and welcome to Python for Scientific Computing 1 video series. In this series, I will be introducing you to Python programming language and show you some basic tasks, scientific and engineering computations that you can do using Python. These calculations are typically what you do in your upper division classes in engineering, particularly civil engineering, as well as in other STEM disciplines. This video should be of interest to a wide range of audiences. In the last lecture, I provided the learning outcomes of this class. And in today's lecture, I'm going to be talking about data types. Data types are fundamental to learning any programming language. So we'll look at what data types are in Python and why do we need them, and also see what type of data types Python offers as part of its for its functionality. So without further ado, let's jump right in and learn about data types in Python. In today's lecture, we're going to talk about what are data types, why do we need them, what are some built-in data types in Python. They're also known as primitive data types or native data types, as well as some non-native or non-primitive data types. And as we talk about data types in Python, I will also introduce you to some Python syntax along the way. In computer programming, what we do is we manipulate data. So we read in data, we create data by running some functions, running some code. We visualize the data. The chart itself can be viewed as a specific type of data, and we can store this data for later use. In Python and in most other computer languages, data is stored in variables. So we create a variable and assign values to it. So if you look at this box, what I have here is a variable called a, and I want to say that the value of a is 5. To do that, I make use of an assignment operator. In Python, we use equal to as an assignment operator, and this 5 is the value. So on the left-hand side, I have a equal to 5, and what this means is that it's telling Python to define a variable a and assign a value to it called 5. Also notice here that I'm using this hash variable assignment. Hash is used to write comments in Python. So whenever Python interpreter sees this hash, it knows that this is a comment line and it skips it because there is no calculations to be made on this comment line. Nonetheless, comment lines are extremely useful for documenting your code and making your code readable. So I strongly urge you to put as many comments as possible, because this not only helps you better document your code, but it also reinforces your understanding of what's happening as you learn coding. So data in Python is stored in variables. What does this variable actually do? This variable serves many purposes. One is that this variable tells what type of data is assigned to it. So a here we saw has been assigned a value of 5, which means it's assigned an integer. So what that means is that you now know that with a, you can perform a certain types of operations that you can subject integers to. For example, you can take the square root, you can multiply it with another integer or another number, things like that. The other thing that this variable does is the variable also tells the computer how much memory is needed to store the value. So since this is an integer that's in decimal logic or a number 5, and computers use binary logic, so computers are going to convert that 5 into a set of zeros and ones and store it. Okay, so each 0 or 1 is a bit, and 8 bits is a byte. So when we talk about megabytes, gigabytes, that's what we are referring to. And so it tells us how many bytes of data are needed to store for A to store this value 5. Okay, so in other words, a variable acts as an interface between us and the computer in making sure that it'll end up doing what we want to do. In Python, Python's an object-oriented programming language, so all variables are also objects in Python. So data types are ways in which data in Python is classified or categorized. So what a data type tells us is that what type of data is being stored in that variable. For example, we saw that a is equal to, in a equals 5, we saw that an integer was being stored in that variable. We also saw that by knowing that it's an integer, it tells us what type of calculations are possible with it and how much memory is needed for that variable, to store that variable. So for example, if I were to store 100 in A, it tells us that A is an integer, so I can do certain types of calculations. And also it will convert that 100 to a binary number or to base 2. And since this is plus 100, it has to keep track of the fact that this is a positive number. So it takes up 1 bit for that, and then 7 other bits. So it needs at least 8 bits to store this number 100. So the data type A essentially tells us that A is an integer, so it'll tell you what type of calculations you can do. And it also tells the computer how much memory is needed to store that value. So integers are not the only data type that are available in Python. Python offers 5 distinct data types that can be broadly categorized into 3 categories: numeric, Boolean, and string. Numeric values are the ones that are of most interest to us in engineering calculations because we work with numbers. And numeric data types in Python include integers. Integers simply are non-decimal numbers. And then floats. Floats are decimal numbers. And then complex are complex numbers. Boolean essentially is holds true or false value. So we write true or false to denote that the variable is Boolean. We use Boolean for making conditions, saying, if the value is less than that threshold, if that statement is true, then we do a set of calculations. Otherwise, we do another set of calculations. Strings are used to store a sequence of characters. You can manipulate strings. That is called unstructured data mining these days. But more importantly, at least in this basic class, in this fundamentals class, we'll be using strings largely to define our data or print out some information related to our variables. So data types in Python, 3 categories: numeric, Boolean, and strings. 5 different data types: integer, floats, complex, Boolean, and strings. So if you want to know what type of data is stored in a variable, you can make use of the type function. So what I have here is a couple of comment lines, again, extremely important. And then I have assigned this large 65 followed by several trailing zeros to A. And then, so clearly A is an integer, B is 3.414, so B is a floating point number, and C is equal to 2 plus 3J, so this is a complex number. So if I were to say type of A, it'll tell you what type it is. And if I want to write that onto a console, I make use of this print function. So the print function writes the type of A. So it first evaluates what this type of A is, and then it prints to the console, and it prints for me the class int. So it's saying that A is a variable or an object that is formed from the class int or of the type int. B is a float, and C is a complex. So a couple of things to keep note here. One very unique feature of Python is that Python can store extremely large integers without any problem. So how long an integer can you store really depends on how much memory you have to store it on your computer. If you can think about it, Twitter uses Python or the same logic to store a unique ID for every tweet, so you can know that millions and millions of tweets are generated each day. You can just imagine how long those integers are going to be. Um, so the other thing to keep in mind is when you do complex calculations, Python uses J instead of I. J is very common in electrical engineering to define an imaginary number, whereas I is used more commonly in mathematics and in other disciplines to define an imaginary number. So just keep those two things in mind as we talk about data types. Similarly, if I were to define a variable x here and assign it a value of true, see that true, the t is capitalized here, and note that true is not in quotes. It simply means that I'm making x a Boolean value, and then y is given in quotes. You can either use single quotes or double quotes to define strings, but you have to be consistent. In other words, you have to use, if you use a single quote here, you should use a single quote here. If you use the double quote here, you should close it with a double quote. Again, if I do print type X, it tells me that it's of the bool class, or the variable is a Boolean variable. And then if I were to print type Y, it tells me that it's a string. Okay, so one word of caution, do not put Boolean values in quotes, and also notice the capitalization. Boolean values can only be true or false. And also integer, float, complex, and bool. A Boolean can only store one number or value. A string can store a sequence of text, although all text between the quotes can be treated as one value, although you can slice it and dice it and perform some calculations or manipulations with it. Uh, while there are 5 primitive data types, Python is not just limited to them. There are other data types as well. These are called non-primitive data types. Non-primitive data types means you don't have access to them anytime you want it. They are hidden in some particular libraries or modules. So you have to first load the module to get hold of this data or to be able to use these data types. Some examples, date is a data type to store dates, and it's available to us in the datetime module. Modules and libraries are a set of functions that are written and made available external to Python, so you can call them in, you can download them, call them in, and use them as part of your Python. So this is a way Python continues to be a lean language without a lot of bloatware. Another reason why we want to create some non-primitive data types is to modify a primitive data type. For example, there is float64 in NumPy module or NumPy library, and that uses 64 bits to store decimal numbers. So you get much higher accuracy with numbers. And sometimes you also have float32 and float16. So if you want less accuracy, you can choose them as well. So some examples of non-primitive data types, I first have to import datetime. And when I import datetime, I can import it as an alias, because every time I want to call a function that's in datetime, I have to put datetime. So instead of that, I give it an alias called dt. So import datetime as dt. And then now I'm defining a variable t and assigning it a value of a date. So I put dt.date 2024, 5, 1. This is year, month, and day. And if I print this value t or variable t, I see that it's 2024-05-31. And then if I print the type of t, it is telling me that it belongs to the datetime.date class, or it has a data type of date, which is not primitive to Python, but is present in this datetime module. Similarly, I can import NumPy as NP. NumPy stands for Numerical Python. We'll be doing some videos exclusively on NumPy in this course, later on in this course. So F16 is the floating point 16. So if I were to take 22 by 7, which is the radius of a unit, area of a unit circle, for example, then, or the value of pi, then when I write it as 16 decimal places, I get 3.143. So I'm accurate to 3 decimal places, or I have a precision of 3 decimal places. If I were to define 32 and use np.float32 for that same value, I get 6 decimal places. And if I use float 64, I get several more decimal places. So the accuracy goes up as I go from 16 to 32 to 64. So these are all various non-primitive data types specific to NumPy. For example, if I were to say type F32, it tells me that it's of NumPy float class and of float 32 class. Okay. Couple of things to keep in mind. Precision of floating point numbers, extremely important in numerical analysis and in scientific computing. The precision does two things. One is clearly if I go to double precision, say float 64, I'm getting a greater number of decimal numbers, okay, which means my calculations are going to be more accurate. But at the same time, it's going to cost me a lot more computer space or computer memory to store this number. So when we are doing one or two calculations, it really is not of concern. But many times in engineering, we do millions of calculations as part of our computing when we're trying to do finite elements or running other complex codes. Then this becomes an important aspect because it hogs up a lot of memory. So then we have to make some decisions as to whether we want to keep this accuracy or should we sacrifice some of the accuracy for speed. So in summary, the concepts that we covered in today's lecture, we talked about variables, and we also saw that in Python, since Python is object-oriented, all variables are also objects that are derived from a certain class. We talked about data types and the important role they play in interfacing between what we want to do and how computer stores the data. We talked about 5 different primitive data types in Python: int, float, complex, Boolean, string. And we also looked at a couple of non-primitive data types, particularly from the date in the datetime module, and then float 16, float 32, and float 64 from NumPy. Of course, if you want access to this non-primitive data types, you have to load the right libraries, and you can do that using an alias to help yourself reduce typing. So as part of this lecture, I also introduced several syntax. The most important one for me, at least, is this hash comment lines, because you need to document your code. We saw how to use the print statement to print out values of the variables onto your computer console, onto your screen. We looked at the import statement to import modules or libraries. And then we looked at a native function called type to get the data type associated with it. So data types are extremely important. We usually don't look at data types every time we write, because for most calculations, we don't have to explicitly define in Python what the data type should be. So that makes it a bit easier. for us to code. Python also does a lot of data type conversions if it can. So it handles a lot of these things, behind in the back end, but nonetheless, knowing what data types are plays a very important role, especially when your calculations are not turning out correct. There is a good chance that there is a data type mismatch that you have to fix before the calculation can proceed. Uh, so again, I urge you to take the quiz that's associated with this lecture. You can also find a PDF of this PowerPoint, um, and I've given you the links to all of them in the description box. So with that, I will see you in the next lecture where we will talk about data structures. And once we have the data types and data structures down pat, we'll go to Google Colab and do some calculations and get our feet wet with programming. Till then, take care, stay safe, and goodbye.